Okay, so my research was done on EcoMonitor. As a quick introduction, my name is Rena and I am a freshman at University High School. So EcoMonitor, it's a device and app used to determine the health of houseplants, and afterwards it can notify the user to make any changes necessary to the plant via an app. The purpose and target audience. The purpose of this device is an app is to help people who want to grow plants, but often forget to take care of them or are too busy to keep track of them. And then the target audience is users who are just beginning or don't have as much experience in raising plants. So the problem, raising plants is really hard, and I've personally had difficulties consistently raising a plant, along with many other people. 66% of Americans own at least one houseplant, where the average plant parent has killed nearly seven, and 48% of plant owners are worried about keeping their plant alive. 50% of Americans also don't leave their house every day, which increases mental stress, and more than 20.9 million people live where year-round particle pollution levels are worse than the national air quality limit, which leads to respiratory and cardiovascular issues. So, the solution. Studies have shown that raising plants helps both mental and physical health. Houseplants have been shown to remove airborne toxins in homes up to 84% in 24 hours, and have shown many positive impacts to the mental health of caretakers, including relieving stress and increasing productivity at work. Those with plants have also been shown to take less sick days off work as it promotes restoration and gives a sense of achievement that cannot be replicated. So, background and brief overview. EcoMonitor is a device and app using an AI algorithm to determine the health of houseplants and it sends reminders to the user to water their plant via an app that shows the moisture levels and health status. And it turns the plant growth process into a more enjoyable process. So tools and coding languages used. For coding languages, we used Python and the Raspberry Pi, and then Dart was also used to code the app, which is a mix of Java, Python, and C Sharp. Hardware-wise, we used Raspberry Pi 5, LED strips, and a plant monitor. And then for software, we used VNC Viewer, Android Studios, Flutter, and Firebase. So overview, we have the app over here with the splash screen, plant selection page, and then all the data. And then it connects to a server, which is connected to the Raspberry Pi, which has a humidity sensor, LEDs, camera, and then the AI-based engine, which does image classification for plant health. So the app, it gives us a plant selection page where we can choose between various different plants. A plant status page that shows if the plant is underwatered, healthy, or overwatered, along with the moisture percentage detected in the soil, when the plant was last watered, and when to set a watering reminder to water it next. And then at the bottom, we have specific care tips depending on each plant. So we also have LED lights. So when the monitor senses a large increase of moisture within the soil, the LEDs become a rainbow color to give sort of like a feedback loop to encourage people to water the plant more. And then for setup, we have the camera, which captures images to send to the AI on a 3D printed stand, and then it sends it to the Firebase database. And here we sort the images that the camera takes. And then we have the plant monitor, which detects the moisture levels of the plant and sends it to the Raspberry Pi. So it's just how much water within the soil. And then we have LED strips, which alert the user when to water the plant. So we have red for overwatered, green for healthy, and blue for underwatered. And now we have the artificial intelligence software that we used with Teachable Machine, and it's a TensorFlow engine. So we just have image samples of underwatered, healthy, and overwatered plants. And then when we show it an actual picture, it can determine the confidence rating that it is one of those three categories. And then here's on the Raspberry Pi, you can see the image of the camera showing the actual plant, and then you can see the AI determines that it's healthy with an 86% confidence, and then the moisture sensor shows there's 32% of moisture in it, which it leads it to believe is overwatered. So our first experiment was testing the AI model's accuracy. So we had three plants of each category, and we tested the accuracy of the AI in determining if it was correct. And then we did multiple trials of this with different plant species, and our results found that the AI was mostly accurate and could most easily identify the healthy plants as they looked the most distinct compared to overwatered and underwatered, which looked a bit more similar. Our second experiment was determining the effect of color LEDs on how motivating it was for people to water the plant. So we measured on the time it took to respond and the user's opinion on the lighting, which was a survey. So like, did they enjoy the lighting or did they find like a certain LED pattern more irritable? So the results found that the time for response was quickest for solid red and blue lights, and the user most preferred solid red lights, however. So some challenges we had during the experimentation process and through the design was transferring the data from the Raspberry Pi to Plant Monitor to the app, and we decided to go through Firebase in the end. And initially we were designing our app through Flutter Flow, but we changed it to Flutter regarding app design because Flutter is a more coding intensive app, which allows us to do more functions with it, and it's easier to like connect to the Firebase database. And for AI training, we had to find over 50 images for each class, and we just went online and found them because there wasn't a current database available for overwatered, underwatered, and healthy plants. And we had to convert all the images to the same file type and size and upload them all. So overall impacts of EcoMonitor, it aims to help people of all ages, making it accessible for people who want to raise a houseplant but are too busy. And it uses reminders, colorful apps, colorful lighting, and our reward system to turn a tedious task into more of a fun game and makes the experience enjoyable while improving personal health. And with our AI engine, we take away the guesswork and unpredictability of raising plants by using real-time data, and like random forums online or various other things aren't as applicable to all plants or environments. And then having houseplants has been shown to improve air quality along with mental and physical health and brings a sense of self-achievement that makes people feel better because they are raising the plant themselves instead of just having some device that does it for them. Thank you. And then you can contact me at my email.